Hi, this is Ibrahim from Pioneer Tutoring. In this session, we'll be going through an example from grade 9 Alberta curriculum on scale factors and similar triangles. So let's start off with the definition of a scale factor. So scale factor is essentially by how much you increase or decrease an object by. So it is an increase or decrease of an object. So if I were to give you guys an example, let's say in the first scenario, so this is, I'm going to say case number 1, and the one at the bottom I'm going to say is case number 2. So in the first case, let's assume the horizontal length is 10, the corresponding length on the other triangle is 5, and then this one is 4, the vertical one on the first triangle, and this one is 2. So this I'll say is my original rectangle, and the one opposite to this is my new triangle, or the new image if you want to call it that. Now in order for me to find the scale factor, I essentially need to use the following formula. So scale factor is equal to length of any of my new image divided by any corresponding length of my original image. So if I look at case number 1, again my new length I can use 2, which is this one, and the corresponding one to this is 4, right around here. So now what I'm going to do is I'm going to plug these numbers into the formula. So it's going to be 2 divided by 4, which when I simplify gives me 1/2, which is equal to 0.5. So my scale factor in the first scenario was 0.5. Now let's say if we take the same example but we flip it around. So now the smaller one is my original image and the bigger one is my new image. So in terms of the dimensions, we'll keep them the same. So this will be 5 and 2, and this is going to be 10 and 4. So again, in this case, the scale factor, the formula remains the same, right? It's going to be new divided by original length. And again, you can use any length. You can use the vertical one, you can use the horizontal one, as long as you're consistent. So in this case, I'll actually use the horizontal ones. So I'm going to use this one here and then this one here. So my new length, new horizontal length is 10 and my original one is 5. So when I do 10 divided by 5, I end up with 2. So in this case, my scale factor is equal to 2. Now from these two examples, what we can conclude is if your scale factor, so I'm going to say a, the variable a is my scale factor, if it's greater than 1, then my new image is going to be bigger. New image will be bigger, or new image will increase in size. And in contrast, if a is less than 1, then my new image will decrease in size. And if you look at the above examples, you can see how it works. So in the first one, my scale factor, which again is a, was less than 1. Therefore, my new image was smaller in terms of the size. And then when I looked at the second example, you can see that my new image was bigger because my scale factor was greater than 1. Now, the second part of this video is going to focus on similar triangles. So the first thing I'm going to do is I'm going to draw a couple of triangles here. Insert triangle. So this one is my first triangle. Then I'm just going to copy and paste this on the side and decrease the size. Okay. So let's assume, these are the two triangles we have. In terms of the lengths, I'm going to put the following one in. So I'm going to say this one is 8, this one is 4, this one is my unknown, so this is what I'm solving for, and this one is 2. Okay. Now, in order for me to solve for my unknown length, which is this one, all I need to do is follow this process. So the process is, I'm going to start off with my unknown variable, which is x, and I'm going to divide it by the corresponding side of the other triangle. So the corresponding one to the x is this 2. Yeah. So I'm going to divide this side by 2, and then I'm going to make it equal to, so I'm going to go back to the original triangle, which is this one, and then use any of the length, right? You can use the horizontal one or you can use the one on the side, but the trick is it must be opposite to the corresponding one on the other triangle, right? So if I'm using 8, then I'm going to have to use 4 on this triangle. Okay, so I'm just going to write this down. So 8 divided by 4. Now I need to isolate for my variable. So my variable in this case is x. So in order to get this by itself, I'm going to have to multiply this side by 2. So this cancels out, and then I must multiply this side by 2. So when I solve for this, x is equal to 8 times 2, which is 16, divided by 4, which gives me 4. And the last thing you want to do is you want to ask yourself, does the answer make sense? So if I look at my number, right, x is equal to 4, and logically speaking, it has to be greater than this 2, right? Which it is, because if you just look at the size, it's bigger in size as compared to the second triangle, right? So this we can say triangle number 2, this we can say triangle number 1. So I can conclude that I've done the question correctly. This takes us to the end of this video. I hope this was useful. If you have any feedback, please provide it in the comment section below, and don't forget to subscribe and like this video. Thank you very much and have a great day.